Hello everyone. In today's session, we will learn how to create an EC2 instance and RDS database instance in a custom VPC on AWS using Terraform. So these are the table of contents which we are going to learn today. So what is Terraform? It is an open source infrastructure as a code software tool where you define and create resources using providers in the declarative configuration language, example JSON. With Terraform, you can package and reuse the code in the form of modules. It supports a number of cloud infrastructure providers such as AWS, Azure, IBM Cloud, etc. So currently, we are using cloud infrastructure provider as AWS, Amazon Web Service. So now let us understand about VPC. So what is VPC in AWS? AWS VPC is a logically isolated section of the AWS cloud where you can deploy and run AWS resources. It allows you to create a private network in the cloud, providing control over the virtual networking environment, including the IP address ranges, subnet, and configuration of route tables and network gateways. So, what are the components of VPC in AWS? First is private subnet. So, no direct internet access is suitable for resources needing enhanced security like database. Second is public subnet. So it has a route to the internet via internet gateway used for resources that require public accessibility, such as web servers. Internet gateway. So a scalable and redundant component that enables communication between instances in a VPC and the internet, allowing resources in a public subnet to connect to the internet and vice versa. Route table for public. So routes traffic in and out of a public subnet, directing it through the internet gateway for the internet access. And for the route table private, it enables the traffic within the VPC, typically without a direct route to the internet. So it is used for communication between instances in different subnets. So security group. So it acts as a virtual firewall for instances. So it controls inbound and outbound traffic based on rules defined by the user, providing an additional layer of security. Last is NAT gateway, a managed resource network address translation service that allows instances in a private subnet to initiate outbound traffic to the internet while preventing inbound traffic and reaching those instances. So it is useful for instances without public IP address. Now, what is EC2 instance and RDS database in AWS? So EC2 instance is nothing but an Amazon Elastic Compute Cloud, which is a web service that provides resizable compute capacity in the cloud. So it allows users to run virtual servers known as instances to host application, website, or any other backend services. RDS database. So Amazon Relational Database Service is a managed database service that simplifies the setup, operation, and scaling of relational database. It supports various database engines such as MySQL, PostgreSQL, Oracle, and MariaDB. Now let us learn about VPC architecture overview, which we are going to use today. So as you can see, this is our VPC. So first we will create two subnet, which is public and private subnet. So public subnet is associated with a route table that has a route to internet gateway via an internet gateway. These resources in public subnet can have an public IP address and can directly access through the internet. On the other hand, private subnet does not have the access directly to the internet. So they are typically used for resources that should not be directly accessed from the internet, such as database. So first, after we create a VPC, which we'll use to isolate and organize our network resources. Then we will create two subnet for MySQL RDS, which is private subnet, and for EC2 instance, we will use public subnet. So after creating two subnet, we will deploy an EC2 instance in our public subnet, which will have direct access to the internet by using internet gateway. And then we will create the two private subnet to the host for MySQL RDS database instance, ensuring secure and controlled access. Then we will establish two route tables, one for the public and one for the private. So public route table configure routes to the internet gateway, allowing outbound internet access for resources in the public subnet, while private route table will restrict the outbound traffic to the internet, providing a more secure environment for resources in the private subnet. And we will use EC2 security group to define our inbound and outbound rules for the EC2 instance. And we are currently using Ability Zone as AP South one, which is Mumbai. So Ability Zone is an data center or facility within a region. So each ability zone is isolated from others but is connected through low latency link. So as we can see, a AWS region typically consists of multiple ability zones. So we can currently see as ability zone 1, 2, and 3. Next, we will create a security group for RDS instance. So this will specify the rules to control traffic to and from the MySQL RDS database instance, which is located in the private subnet. So after this, we will verify the setup by confirming that EC2 instance can communicate with the MySQL RDS database securely. So to connect an Amazon instance in a public subnet to an RDS instance in a private subnet, we have to follow some general steps. So we need to create a security group configuration which will ensure the security group associated with the RDS instance, which allows inbound traffic on the database port, which is 3306 from the security group associated from the within the EC2 instance. And the VPC configuration will make sure that both the EC2 instance and RDS instance are same in the VPC. And the private subnet for RDS will place the RDS instance in the private subnet within the VPC. So this subnet should not have a direct route to the internet. Then we will use DNS resolution. So if the RDS instance has a DNS endpoint, which will ensure that DNS resolution is configured appropriately within your VPC. So it can resolve the DNS name of the RDS instance. So to connect from EC2 to RDS, we need to update our application on database client on the EC2 instance to use the DNS name and IP address of the RDS instance while connecting to the database. So what are the requirements? So EC2 instance should be accessible anywhere on the internet via HTTP. So everyone should be able to access the EC2 instance via SSH. And RDS should be on private subnet and inaccessible via the internet. And only the EC2 instance should be able to communicate with the RDS. So prerequisites are to install Amazon CLI. Terraform should be installed, and Visual, I am currently using the editor called as Visual Studio Code. And to connect EC2 instance, I am using Mobaxter tool. So now we will start with the implementation. So this is the summary view of the Terraform file in our Visual Studio Code editor. So our first step will be to create a provider.tf file. So the provider.tf file in Terraform is a configuration file that specifies the cloud provider and its corresponding plugin that the Terraform will use to manage resources in that provider. So this is the code for the provider.tf file. So first we have to create a provider.tf file. So this block of code will declare the required provider for the configuration, specifying that the HashiCorp AWS provider with a version greater than or equal to 5.0 is necessary for a required configuration. So the provider, as you can see, this is the provider block where we have given the provider name as AWS as we are currently using AWS, and we have specified the region which we are going to use is AP South 1, which is Mumbai. And this is the access and private key file which is set to default. And the data AWS availability zone, which is the state is set to available. It filters the source to query information about all the availability zone of AWS, and it filters only for the available availability. So this code will essentially set up the Terraform configuration to use the AWS providers, which specifies the AWS region and profile to be used, and gathers information about available AWS availability zone in the specified region. Now next, we will create a vpc.tf file. So VPC file typically contains configuration code for creating and defining Amazon Virtual Private Cloud along with its associated resources. So now we will create vpc.tf, and in this we have created our VPC. So we have given the resource name to create a VPC as AWS VPC, and we have given the name for that VPC is tutorial VPC. So here we are setting up the CIDR block of the VPC. So it will set a classless, which is CIDR means classless inter-domain routing block for the VPC. So this block value is obtained from the variable which I have given as var.vpc block. So it will define the IP address range for a VPC, and the DNS host configuration will enable the DNS host names for the VPC. So this means that instances launched in the VPC will receive public DNS host names that will correspond to their public IP addresses. So the tag name I have given as tutorial VPC. So the tag name will provide a better identification and organization. Next, we will create a subnet.tf file. So a subnet.tf file in Terraform defines and configures subnets within a AWS virtual private cloud, and specifying attributes such as CIDR blocks, availability zone, and route table association. Now create subnets.tf file. So first we need to create a subnet for public. As we have learned in architecture, we need to create, there are two types of subnet, which is public and private. So we need to create one public subnet and two private subnet. So the resource name I have given to create a subnet, AWS subnet, and the name for our first subnet is tutorial public subnet, which is a public subnet. And the count parameter will allow for creating multiple subnet based on the value of the var.subnet count public, and it is associated with the subnet with specified VPC ID and CIDR block and the availability zone. And the tag name for our first public subnet is tutorial public subnet. Now we will create our second subnet, which is private subnet. So the structure is similar to the public subnet. So the count parameter for multiple private subnet is based on the value for our variable subnet count dot private, and it is associated with the subnet with the specified VPC ID, which is AWS VPC dot tutorial dot VPC ID, and the CIDR block, which we have mentioned in the variable dot tf file, and the availability zone. So as you can see, the subnet count for public it is set to 1, and for private it is set to 2, and this is the variable for our VPC CIDR block, which is set to default, and the IP we are using is 10.0.0.0 plus 16. So let's go back to our subnet.tf file. So the tag name I have given as for private subnet tutorial private subnet. So this resource block will generate multiple subnet based on the count specified in the variable. So as you can see, in variable.tf file, I have specified the count number for public as well as for private subnet. So public is set to 1 and private is set to 2. So we have specified the count number and each with its unique CIDR block, availability zone, and naming convention for improved manageability. Now we will create a security group. So the security group TF file in Terraform is vital for configuring application security, focusing on security groups for EC2 instance, RDS instance. So within this file, you define security group configuration for EC2 instance, RDS database instance, and specifying the open ports and allowed protocols for inbound and outbound traffic. Now we will create security group.tf file. So our first security group, so we will create first the resource name is given as AWS security group, and the name for our first resource is for tutorial web page, which will create the security group for our web page, for our web server. Now, so we have to mention the name and the description and the VPC ID. The VPC ID is must, as the security group will be created in this VPC, and our VPC name we have given as tutorial VPC. So egress block we define the inbound and outbound rules. So in egress block, as you can see, it will allow the traffic to through HTTP port, and the default port is 80, and the CIDR block are set to be allowed for everyone. And in the next ingress block, you can see it will allow SSH from your computer or any other computer, which is set to be to allow everyone, which is set to be 000 slash 0. And the outbound rules will allow all the outbound traffic. So the tag name for our first security group is tutorial web HTTP, which we have seen. Now we will create a security group for the RDS instance. So first we will take our resource name as AWS security group. Then we will define the name for the security group, which is tutorial DBHE, which means tutorial database security group. The name, as you can see, tutorial database security group. And the description is given for security group for tutorial database. And the VPC ID, which we have created earlier, which is aws vpc.tutorial vpc.id. And the inbound rules, which is English, is set from port 3306, which is the default for all MySQL traffic, which will only allow the web security group to have the access. And the protocol is TCP. And as you can see here, I have mentioned the security group of the web server. And the tag name for our security group for RDS instance is tutorial DB SG. At the last, we will create a DB subnet group named tutorial DB subnet group. So the resource name I have given is AWS DB subnet group. And the name for the resource is tutorial database subnet group. So the subnet IDs I have given for subnet in AWS subnet tutorial private subnet.id. So this will create a database subnet group for RDS instance and associate the group with the private subnet created earlier. So this code will establish security configuration for both the web server EC2 instance and the database RDS instance, ensuring control access based on the specified rules and subnet association. Now we will next create EC2 instance.tf file. So the EC2 instance.tf file in Terraform typically contains configuration for creating Amazon EC2 instance. So it will define the instance type, Amazon machine image, key pair for SSH access, security group, and other settings. Now we will create EC2 instance.tf file. So as you can see, here we have created an EC2 instance. So the resource name to create an EC2 instance is AWS instance, and the name for the instance is tutorial web. So as you can see, the tag name is also set to tutorial web and the count.index. As we have seen in the variable.tf file, the count is set for the public is 1. So here the allocated storage, so this will the count will create a multiple EC2 instance based on the specified count, which we have seen which is set to 1. And the AMI which you are currently using is Ubuntu. So this is the AMI ID for a Ubuntu, and the instance type which define the instance type for a EC2 instance, and the subnet ID which is public, as this instance will be created in a public subnet, and the key name which I have given is retire. You can give your key name as per a requirement, and the VPC security group ID is set to the web security ID which we have created earlier, and the tag name for our EC2 instance is tutorial web. Now we will create database instance. So the database instance.tf file typically contains Terraform configuration for creating an Amazon RDS instance. So it defines settings such as database engine, instance, class, allocated storage, other parameters. So now let's create database instance.tf file. So the resource name which I have given is database instance. So we can also refer this code from the Terraform registry. So to refer the code, we just need to type in the search bar as Terraform registry, which will open the default page of Terraform registry. And these are the feature provider name. So we are currently using AWS as our cloud provider. So click on AWS, then click on documentation, and then simply you can write AWS, the resource name which you want. So as you can see, I have typed RDS and it will showing the current the resource which are under the relational database. So click on the AWS database instance and in below, as you can see, this is the code for the database instance. You can refer this from Terraform registry as well. So the Terraform, so now we have created a resource as AWS DB instance, which is database instance and given the name as tutorial database. And we have allocated storage to 10. We specify the allocated storage for our RDS instance and the engine name which we are currently using for our RDS is MySQL and the version for and the engine version is 5.7. So in instance class is set to db.t2.micro, which is for free tier, and the username I have given is admin and the password is admin1234567 8 and the database name is tutorial. The parameter group name is set to default to MySQL 5.7, which is the version. So skip final short is set to true, which will skip the final database short during the deletion. And the database security group name will specify the database subnet group, which we have created in the security group. And the VPC security group ID for the database we have created earlier is mentioned here. So it will associate a security group with the RDS instance. Now we will create a route table. So the route table file in Terraform is responsible for configuring route tables crucial for directing the network traffic within a VPC. So by creating a route table to route traffic through the internet gateway, we will give internet access to the VPC. So now we will create a vpc.tf file. So now we will create route table for public as well as for private subnet. So this Terraform code will define the route table and associates them with the public and private subnet with the previously created VPC. So first we are going to create a route table for public. So as you can see, the resource for to create AWS route table is AWS route table and the name is tutorial public. I have given as tutorial public RT, which means public route table, and the VPC ID is equal to AWS VPC tutorial VPC ID, which we have created, and the route is set to all of the default route to the internet gateway. So this will allow the gateway ID will allow the outbound internet access. Now we will associate the public subnet with the public route table. So as you can see, to associate, we need to give the resource name as AWS route table association, and the name is public, and the count is set to be var.subnet.count.public, and the route table ID is AWS route table tutorial public rt.id, and the subnet ID is AWS subnet.tutorial public subnet. The count which is set to 1 for the public subnet, which we have seen previously. Now we will create a private route table named as tutorial private route table, and we need to just specify the name of the VPC. So here we have specified the VPC ID, which is AWS VPC tutorial VPC.id. So this will associate each public subnet with the tutorial public RT route table. So the count parameter will allow for associating multiple subnet public subnet. So now we will create a route table for private. Now we will create a AWS route table association for a private route table. So the count is where.subnet count.private, and the route table ID is private route table ID, and the subnet ID which is set to AWS subnet tutorial private subnet count.index. As you can see, the count.index we have specified in the variable.tf file, which is set to 2. So it will create two private subnet. So each private subnet with the tutorial private route table will allow to associate the multiple private subnet. So in summary, this code establishes the route tables for public and private subnet within the VPC. So the public route table is associated with the public subnet, allowing outbound internet access, while the private route table is associated with the private subnet for internal communication. Now we will create an internet gateway. So internet gateway will provide the access to the public subnet. So this file typically configures the creation of an internet gateway for Amazon Virtual Private Cloud in AWS, enabling communication between instances within the VPC and the internet. So now we will simply create an internet gateway. So to create an internet gateway, I have taken the resource name as AWS Internet Gateway, and the name for that resource is tutorial IGW, means Internet Gateway, and the VPC ID we need to mention. So this will create an internet gateway within our VPC. So VPC ID is AWS VPC tutorial VPC.id, and the tag name which I have given is tutorial internet gateway. Now let us move on to next. We will create an elastic IP. So an elastic IP.tf file in Terraform is used to define and configure elastic IP resources in AWS. So providing static public IP address that can be associated with EC2 instances or other resources, allowing them to be accessed consistently over the internet. Now let us create an elastic IP.tf file. So to create an elastic IP, we have to take the resource name as AWS EIP, which means elastic IP, and the name I have given for an elastic IP is tutorial web elastic IP. So the count parameter allows for creating multiple elastic IPs based on the value specified in the var variable.setting web app count, and the instance it will be associated with an specific EC2 instance using the AWS instance tutorial web count ID, and the tag name for our elastic IP is tutorial web elastic IP. So in summary, this code will generate elastic IP resource for EC2 instance, allowing the instance to have static public IP, which can be beneficial for scenarios where you want to ensure consistent IP address for your EC2 instance, especially in dynamic environment. Now, as you can see, next we have to create variable.tf file. So here we have to define input variable for our infrastructure code, which will allow customization and flexibility for parameterizing value that can be easily modified without changing the core code. So first I have created a variable for our VPC cider block, and which we have seen earlier, and the subnet and next block is for subnet count, which we have set one for the public subnet, and for the private subnet we have set it to 2. Next block is for variable setting, which will define our configuration setting. So we have earlier created a database instance which is allocated storage with 10 GB, and engine we have used as MySQL engine version is 5.7, and instance class is db.t2.my, and the web app is set to count is equal to 1, and the instance type is t2.mic. Next we will create a variable for a public subnet cider block. So this will create a default IP address for a default IP address. So as you can see, there are 4 default IP address, which is 10.0.1, and which is set to till the 10.0.4 IP address. Now in next block we have defined the variable for the private subnet cider block, which will create a default IP address, which have default IP address, as you can see, 10.0.101.024 till the 104. So this will create the cider blocks for our public and private subnet. So these variables provide a way to parameterize and customize the infrastructure deployment. So it will make more flexible, and we can reuse this code. That's why we have created variables.tf file. Now we will create output.tf file. So an output.tf file in Terraform defines the output value that you want to display after an infrastructure deployment, providing a way to expose specific information such as resource ID or computed result for easier access or use in subsequent process. Now we will create output.tf file. So in our output.tf file, we need to have the output such as web public IP address, web public DNS name, and a database endpoint and database port. So we just need to describe for the web public IP, the public IP address of the web server is needed, and the value which is set to for the AWS elastic IP. So it will throw the elastic IP address, and it will is depend on the elastic IP address. So this block of code will give us the public IP address for elastic public IP address. And the next block for is for web public DNS, which will specify the public DNS address for our web server. And then our database endpoint will also be displayed after we will apply all this configuration. And at last, the database port which we have entered earlier, which is 3306, will also be useful when we apply the configuration. So this is the output.tf file. So this output.tf file variable provide convenient access to key information about our deployed infrastructure after the Terraform execution. So by using this output.tf file, one can refer to obtain details as we have seen as web server IP, web server DNS, and the database endpoint and database port. So now we will deploy our configuration in. So it will create the resources in AWS. Now open an integrated terminal. Now here just type Terraform in it, which will initialize all the provided plugins. So as you can see, Terraform has been successfully initialized. Now just type Terraform plan, which will show what are the resources we are going to create. So as you can see, plan 16 to add, 0 to change, and 0 to destroy. So these are the resources which are going to be added in our AWS. Now type Terraform apply, which will apply our configuration in the AWS. Auto approve and enter. So as you can see, AWS VPC tutorial first file is creating, and all the files which we have planned first now are getting created. So as you can see, after we apply, the 16 resources are added, and in the output.tf file, we have mentioned what are the outputs we require. So now you can see it have given the outputs such as public IP, our DNS name, our database port, and also the database endpoint. So for we will refer this to connect our EC2 instance to our RDS database instance. So now we will connect the RDS instance. So first we have to connect the instance using the MOBAC term to perform our operation. And once when we have connected our EC2 instance, we will try to connect the RDS instance. So first open the MOBAC term tool. Now add a session here. So as you can see, the public IP, web public IP, just copy the IP from the outputs and now select SSH. In remote host, just type our public IP and the username is Ubuntu. Click on advanced SSH setting, use the private key. I have used the private key as 3-tier. You can use your. So as you can see, it is authentication. with the public key. Now it has connected successfully. So the EC2 instance have connected successfully. Now let us clear this and we will update the system as well as we will install MySQL client. So press enter after the typing command. Now it will install all the necessary update and also will install MySQL client. So all the packages are downloaded successfully. Now clear the screen and so once the MySQL client is installed, now we will try to connect the RDS instance. So first the database endpoint is going to be a database endpoint from our Terraform output and the database port is going to be a database from port from the Terraform output and the username which we have created for our database which is admin. So we need to just type this in our Mobex tool. So now in place of the DB username, you need to type your username, which is admin. And in place of the database port, you need to copy the port number from our Visual Studio from the outputs. So the port number, as you can see, database port number, which is set to 3306. Just copy this and paste in the comma. And the endpoint, so the database endpoint, you also need to copy this. Now we will Now press enter and type the required password, which is admin 1234567 8. So as you can see it has been connected successfully. Now we will simply test it by simply typing show database. So it will show our database. So as you can see, these are the database present. So now we will verify the resource created in our AWS console. So first we will check for our EC2 instance. So we have successfully connected our EC2 instance to our RDS instance successfully. So now as you can see instances are running, click on this. So as you can see, this is our IP which you have connected to with the help of Mobexter tool. So as you can see the VPC ID which we have created is tutorial VPC. Now we will check for the VPC. So just type in search VPC, click on VPC. So this is the dashboard of VPC. So as you can see, the subnet, VPC, route tables, and internet gateway. So click on VPC and you can see tutorial VPC which we have created and click on resource map. So as you can see, there are two private and one public subnet. And this is the internet gateway where it is used to access the private public subnet for the EC2 instance. Now we will check security group. Just type security group, click on security group and you can see the database security group and web security groups has been created successfully. So as you can see, this is the web security group, and you can see the inbound rules. So the port is set to 80 and 22 respectively. Now we will check for database security group. So as you can see, the database port range is set to 3306, which we have seen. Now we have also seen the internet gateway, and now we will see the RDS instance. So just type RDS, click on RDS, and click on database, second option. And as you can see, this is the database created. So the engine is MySQL. The region as abilities one is AP South 1P. And this is the ID for VPC subnet to private subnet. And the port is 3306. So we have successfully performed our practical. So here we can conclude for today's session. So utilizing Terraform to create an EC2 instance and an RDS database within a custom VPC on AWS streamlines infrastructure deployment, enhancing scalability, security, and automation. So this approach will ensure a well-architected environment seamlessly integrating compute and database resources while adhering to best practices in cloud infrastructure management. So for reference, as we have seen earlier, you can visit Terraform registry, and if you have any query, please contact us. Thank you.